Find the volume of the solid obtained by rotating the region around the given axis. Okay, so this time we have x squared plus y squared equals 9. We're given an equation in implicit form, not explicitly. And x is greater than 0, y is greater than 0. Rotate around x equals 3, so we have to decide what we're going to do. Okay, so let's go ahead and turn this into an equation that we actually recognize. So this is going to be x squared over 3 squared plus y squared over 1 squared equals 1. So this is the equation of an ellipse. And we're going to take the x greater than or equal to 0 and the y greater than or equal to 0. Okay, so what we're looking at is here. What we're looking at is an ellipse where the x direction, we're going to go 1, 2, 3. Y direction, we're going to go 1, but we want only the region that's above the x-axis, above the y-axis. Okay, y greater than, so it's just this region right here. So it continues on this way, of course, but the region that we're interested in is this region right here. Now they say rotate around x equals 3. So that's this axis right here. So when we rotate around that axis, we're going to end up getting that. That region. We're going to take a slice of that region. We're going to take a slice perpendicular to the axis of rotation. The axis of rotation is vertical, so the slice we're going to take is horizontal. So our representative washer, when we slice this solid, our solid is this. When we take a slice of it, we're going to end up getting a washer. So when I take that washer and turn it a little this way, it's going to look exactly like you think it's going to look. It's going to look like this. Just like that. And it's going to have a thickness, which is going to be dy. So when we add up all these washers, we're adding them vertically, so we're going to be integrating along the y-axis. So integrate along the y, and we're going to be integrating from 0 to 1. Nice. Perfect. Okay, so far so good. Now we're integrating along y, so we need to express these functions as functions of y. So we're going to turn this into a function of y. Okay, so we've got so let me just write that out. So integrating along y means expressing functions as functions of y. Functions of y. Now I've got x squared plus 9y squared equals 9. I've got x squared equals 9 minus 9y squared. I have x equals radical 9 minus 9y squared. Don't worry about simplification. Just leave it as is. You know, pulling out 9s and 3s, and it's not even worth it. Okay, so now let's go ahead and talk about our inside radius and our outside radius. So let's talk about our outside radius first. So I'll go to black. We're going to measure from the axis of rotation to the original function. Well, the outside radius is that one. The inside radius is this one. So the outside radius, well, that's just 3. Nice, because it stays always, it's always 3. The inside radius, that's the radius that it's going to be short, short, long, 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 long. That's the one that changes. So inside radius, well, it is going to be 3. It's going to be this distance minus this distance, because we want this distance right here. So this whole thing minus this thing. Well, this thing is that. So it is 3 minus radical 9 minus 9y squared. There you go. Now that we have that, very, very simple. We have our volume is equal to the integral from 0 to 1 of pi times the outside radius, which is 3 squared, minus the inside radius, 3 minus radical 9 minus 9y squared, squared dy. That's it. This is the integral that we were looking for. Now let's go ahead and see if we can solve this. So we have volume is equal to pi times the integral from 0 to 1 of 9 minus 9 minus 6 times 9 minus 9y squared under the radical plus 9 minus 9y squared dy, which is equal to pi times the integral from 0 to 1. This 9 and this 9 cancel. Negative sign, this becomes 6 times the radical of 9 minus 9y squared. This becomes a minus 9, and this becomes plus 9y squared dy. I just go ahead and plug this into my calculator, and I get myself 8.14. That's my volume. Now, once again, you should note that some of these integrals so some of these integrals you have not learned how to deal with yet. So don't worry about it. That's absolutely fine. So some of these integrals you have not dealt with formally. We have not dealt with it formally. We will very, very soon. You have not dealt with formally. Okay, that's it. That is volumes by the method of washers. Thank you so much for joining us here at Educator.com. We'll see you next time. Bye-bye.